Welcome to Train Signal. I'm Mel Haynes, and in this video we're going to spend some time looking at failover clustering. Failover clustering is a way to give you high availability with SQL Server by providing multiple nodes in what's known as a cluster, a failover cluster, that can be automatically activated or automatically brought online as needed in the event of a failure. Now, one thing to note about SQL Server failover clustering, it runs on top of Windows clustering, which is not a cheap option. The hardware cost for installing failover clustering is pretty significant. In this video, I'm not going to be running on hardware of that nature, so I won't necessarily show you all of the steps to install clustering. But I do want to give you a good understanding of what clustering is about and hopefully get you started on implementing clustering. So overview. In this video, I'm going to basically focus on three things. What are the terms? What are the concepts? What are the things you're working with when you're working with clustering? Second, what are my prerequisites? I just mentioned a big one. Windows clustering has to be in place. So we'll talk about some of those prerequisites in detail, and then I want to talk about some of the different approaches or options you have for working with clustering. So with that, let's jump in. Let's start with key terms. There's 12, at least for now. We're going to focus on 12. First of all, the SQL Server virtual server. Your SQL Server virtual server is basically a cluster configured resource group that simply contains all the resources that are needed for your SQL Server to operate on a cluster. So what does this include? Well, it includes your NetBIOS name, a TCP IP address, and all the disk drives and vital SQL services required to operate in your clustered configuration. The next term, heartbeat, right? What's a heartbeat? Well, in the SQL Server clustering realm, it's simply a single UDP or user datagram protocol packet that is sent at a regular interval between nodes in a cluster. It's basically saying, hey, I'm alive, hey, I'm alive, hey, I'm alive. The default value or default interval is simply 500 milliseconds between pulses. If in the required interval there's no response, that indicates a node is no longer alive and the cluster begins the failover process. As I mentioned, the interval can be changed in SQL Server 2008. The fact that you can change it is awesome when you consider the fact that these clusters could be geographically very far apart. So the time for those pulses to reach their destination could be increased and impact your performance. So you want to adjust the pulse rate based on the distance between your servers. Failover. Well, we're talking about failover clustering, and it's simply the process of bringing a new node online. Failover happens automatically. The reverse of failover is failback. Let's say you're dealing with a two-node cluster, and once the initial node that failed is brought back online, you may choose to move production back to the initial node. That's simply your failback. Next, we have a quorum resource, also referred to as the witness disk in Windows Server 2008, and this is the shared disk that holds the cluster's configuration information. Now, all of your servers will have to be able to contact the quorum resource to become part of an SQL Server 2008 cluster. Another way to think of a custom resource that's probably closer to the way an SQL Server guy thinks, think of it as your log file. In the event that a change or something happens on the primary node and that node crashes before that information can be propagated over to other nodes, when those secondary nodes come online, they can read the quorum resource to find out what additional information didn't quite make it into their system before the primary crashed, synchronize themselves, and come online ready to go. Now, in the event that your quorum resource is also corrupted or compromised, chances are your other cluster nodes will not be able to operate. Another important term, your resource group. A resource group is simply a collection of cluster resources such as your SQL Server NetBIOS name, TCP/IP address, and any other services belonging to the SQL Server cluster. The resource group actually defines the items that fail over to the surviving nodes during a failover. One other thing to note, your resource group is owned by only one node in the cluster at a time. So it's never owned by more than one node, but only the active node owns the resource group. Cluster resource. This contains your vital information for the SQL Server virtual server and includes things such as its network TCP/IP addresses, its NetBIOS name, disk, and any SQL services such as your system attendant. These are the resources that are added to your services or applications when the virtual server is created to form your SQL Server virtual servers. Next, we have a dependency, and your intuition serves you correctly. Anything that your cluster needs in order to operate is considered a dependency. You actually specify your dependencies when you're creating your cluster resources. So before a cluster resource can be brought online, the resource defined as a dependency must be brought online first. Makes sense. Then there's majority node cluster. In a majority node cluster, that quorum we talked about before, that shared disk, instead of it being one disk, it's actually the result of each node contributing disk space to form this logical disk for our quorum. Then there's failover cluster management. Failover cluster management, which was formerly known as your cluster administrator, is the tool used by your cluster and database administrators for accessing, creating, and administering your Windows clusters. It's included with Windows Server 2008, and you can launch it from actually any active node within the cluster. Cluster witness disk or file share. This helps determine your cluster state. It actually stores additional configuration information and is very helpful if not all of the cluster nodes can be contacted. And then last on our 12 key terms to know is the logical unit number. The logical unit number identifies a disk that's presented to a host. So whatever your shared storage device is, when it presents a disk to the host, each disk presented will have a unique LUN value. So those are our 12 key terms to know for SQL Server failover clustering. Now, before we can begin to install SQL Server clustering, there's a few prerequisites you have to have in place first of all. Starting with, well, you need to have more than one server, right? 2 or more identical, and that's the key point. Identical servers are going to be required. Operating system. They should be running Windows Server 2008 Enterprise or the Data Center Edition. Next, you want 2 network interface cards per server. Fourth, shared disk storage is going to be required for your witness, your database, and your log files. You have a myriad of choices of what that's going to look like, such as a SCSI or a SAN or an Internet SCSI, but you'll have to have shared disk storage. The Distributed Transaction Coordinator will need to be installed if you have the following components installed in conjunction with each other. If you have the database engine, integration services, and shared components, you'll also need to have the Distributed Transaction Coordinator. A real easy one here, you'll need to have identical drive letter mappings for all of your shared disks. Make sure you allow SQL Server access through the Windows firewall. Before you start the installation of SQL Server, you'll want to have the failover clustering feature from Windows configured first. You'll need to have all of your clustering groups and your resources available, operational, and online. So once again, when you're looking at SQL Server clustering, 80 to 90% of it is getting your Windows clustering in place first. Separate service accounts are going to be required for your cluster server and for your SQL Server services. Make sure all your software, your hot patches, and all of those things are identical on all your servers. Prerequisites continued. Make sure NetBIOS is disabled on all your network adapters being used for your private heartbeat network. NetBIOS must be disabled. Here's one you'll have to check with Microsoft with just before you come up with your own configuration. What's on the hardware compatibility list? Is all of my stuff covered? Microsoft is basically pulling away from providing support for any non-compliant hardware when it comes to clustering. So you want to make sure everything is on the Windows catalog and the hardware compatibility list. Next, make sure your network adapters are actually listed in the order in which they're accessed by your network services. So for example, your public adapter should be first and then your heartbeat adapter. Next, you'll want separate network names and IPv4 addresses for each services and applications group. Next, all servers must use DNS for name resolution. That's a requirement. All servers must be in the same domain. All servers should have the same domain role. Ideally, all should have the same domain role. So that's the list of prereqs for installing SQL Server failover clustering. Believe it or not, installing SQL Server clustering is actually really easy. The wizard just is kind of point and click and it happens. It even is smart enough to pick certain configuration options based on your Windows clustering configuration. So most of the work goes into planning and setting up the Windows clustering, which also is not extremely complex. It's actually more expensive than complex to set up. For this video, I don't have that kind of hardware in place. We're talking 5-digit hardware costs. So what I do want to do though is just kind of point you in the right direction, show you some of the interfaces you'd use to start the SQL Server clustering installation. So here, let's jump over to my server. Let me get you minimally started on the actual install of SQL Server clustering. Now, once again, you can't actually install SQL Server clustering until you have Windows clustering in place, which requires a significant outlay in hardware. So, but we'll at least point you in the right direction. Now, I already have SQL Server installed, so I can go into the SQL Server group and go to Configuration Tools. If you don't have it installed already, you'll want to get to your installation media. Click on the setup. So eventually that brings me to the SQL Server Installation Center. First screen is all about planning. The second screen is all about installation. And the second option on the list, New SQL Server Failover Cluster Installation, will launch the wizard to install a single node for SQL Server 2008 Failover Cluster. If you want to add additional nodes, there's another wizard just below that, but I'll go ahead and pick the first. It's going to ask me for the location of my installation media, since I'm doing an addition to what I already have in place. And it chugs along through the usual process. Eventually, however, it's going to get to the point where it does a system check to see if I have a cluster in place. That's going to come back with a bunch of failures because I don't yet have a Windows cluster in place. So you'll need to have your Windows cluster all set up first, as we talked about in the prerequisites, and then you can run through the wizard. But I just wanted to give you a little starter on where you go to start the cluster installation process, point out the wizards, and just kind of help you to know that it's very similar, at least initially, to the install of SQL Server. So when we talk about SQL Server clustering, we actually have a few different options. Most of what many people think of initially is single instance failover. A server dies, you have another server that takes over, so you have one that's active and one that's passive, versus multi-instance failover. With multi-instance failover, you can have multiple active servers at any given moment. But here, once again, the single instance failover is typically talking about an active and a passive node, so two nodes. But with the multi-instance failover, you can actually have multiple active nodes. So for example, let's say you have 2 nodes again, and that's the minimum for a multi-instance failover, 2 nodes, both of which are active at all times. Now, in the event of a failure, the processing that was being completed on node A gets moved over to node B. So it therefore takes over all the processing. How do you handle that? You're going to greatly upsize your server to be able to possibly handle all the processing. So you're not saving any money, but you're giving greater availability based on the fact you can move the loads around between servers automatically. Another option is a multi-node cluster. Now this is basically a derivation of the multi-instance failover clustering. The difference in this scenario, more than 2 nodes are configured within the failover cluster and they share the same failover node in the event of a failure. So for example, let's say you have 3 nodes. There may be 2 active and 1 passive, or 4 nodes with 3 active and 1 passive. Now this solution reduces the hardware cost because you don't have the one-to-one mapping between active and passive nodes. So in the case of 3 active and 1 passive, in the event that any one of the nodes goes offline unexpectedly, the 1 passive node takes over that workload. Now, if 2 nodes, however, go offline, the passive node will now have to have the capacity to handle the multiple offline primary nodes. Now, the chances of this probably aren't extremely high, but I think it's called Murphy's Law. If you leave the door open, something will go through it. But here, one more time, running through this. When I'm talking about multiple nodes, you'll need to look at what operating system and what version of SQL server you want to work with. You can go with up to 8 nodes if you're working with SQL Server Enterprise Edition on Windows Server 2008 Enterprise Edition or Data Center Edition. If you don't need more than 2 nodes, you can save yourself a boatload of money by going with SQL Server Standard Edition on Windows Server Enterprise Edition. So we've been talking about clustering in SQL Server 2008. The first thing I did was make sure we're all speaking the same language. We talked about some of the key terms and concepts you'll need to be familiar with if you're going to work with clustering. And we talked about the prerequisites. And that's really the biggie for SQL Server 2008 clustering. Setting up your Windows clustering environment is 80 to 90% of the work, and then the SQL wizards actually take care of about the next 9%. So you got about 1% of point click pay attention to really focus in on. Where do I begin? We actually got you started, didn't get you too far down the path because it's not very long before you run into the hardware having to be in place before SQL says, hey, the stuff isn't there yet. It's going to look for that Windows cluster to be there before it will run the SQL install, but finding it is the same place you would go to install SQL Server or to add components to SQL Server. And then I talked about some clustering options just to give you a feel for what you have to choose from and to hopefully give you what you need to start to make a wise choice. So with that, we come to the end of this video. So I look forward to seeing you in the next video.